Hi, I'm Lisa New. I've been working on the skin disease prediction project for this assignment. Today, I'll be talking about the development of an AI model for skin disease diagnosis. First, I'll tell you the project objectives. I developed this model because I believe that it has the potential to make a significant impact on the way skin disease are diagnosed and treated. As you know, the incidence of skin disease has increased in recent years. This is due to a number of factors: climate change, pollution, and poor air quality. Early diagnosis of skin disease is important for preventing infections and improving treatment outcomes. However, most people do not have the expertise to accurately distinguish between different skin diseases. This can lead to misdiagnosis, which can have serious consequences. I believe that my AI model can help address this issue. My content is import library and data load and visualization and data cleaning and preparation, custom dataset and data transform. And finally, I can learn the model training by using PyTorch, deep learning model, and evaluation and tuning by change the epoch. And I'll test the model with the test dataset. In this section, there are three kinds of libraries: the data handling libraries and visualization libraries and modeling libraries. We use the PyTorch library. So let me tell you about the data. There are six skin disease levels like chickenpox, cowpox, healthy, and HFMD, and measles and monkeypox. And this is my data set. So now, as you can see from the data code output, this data has not been cleaned. You can see that the duplicate data is visible at the chickenpox data. Therefore, data cleaning is performed in the following process. There are three duplicates in chickenpox data, so I remove the duplicate image by using the image hashing. And I execute this code. The remove total two duplicate image in the skin this original data. So this process is the code below is to delete the duplicate image data by using the hashing library. By hashing the image, an image can with the same hash value is deleted because it is duplicate data. And I'll split the original data to train and validation and test data. Now we can transform the clean data. Before the transform data, we have to check the clean data set in at here. And now you can see the duplicate chickenpox data is removed. So in this section, the levels are directly saved in the dictionary form from 0 to 5. This is because model learning should be labeled in integer form rather than string form. So this is the 0 to 5, the level, the change the string to integer, and I got the transform in at here. So in this code, I use the image resize and vertical flip. The probability is a 50%. Also, the horizontal flip is probability is 50%. And I random rotate 90 degrees, and the normalization mean is 0.5, and the variance is a 0.2. So I transform and clean data is also completed. So now I can train the model data, and I already trained the data. So I use the full model to decide the model which is the best. And I have already learned the model and saved the loss value and accuracy value for each epoch. I will select a model by looking the visualization data. There are four model history in the following code. The result of the learning training epochs per model were combined and visualized. Looking at the visualization data, the loss value are ideally decreasing as we learn, like this. And to evaluate the performance of the model, you should look at the accuracy. First of all, EfficientNet V2 model is the deepest model, so it records a high accuracy in this graph. And then I tune the epoch in the MobileNet and the ResNet model. The recently value is the low in the validation data in resonant data. In this case, the accuracy may be low when the actual test is conducted. Also, MobileNet also show the accuracy close to 90%, but it is difficult to expect a constant accuracy because the deviation is too severe for each epoch. Finally, I decided to select the efficient net. It showed the highest accuracy and the deviation was the least for each epoch. So I test the final model with the test data that are not used for training and validation. Testing with new data allow real users to predict accuracy when using the model. In the case of ResNet 50 model and MobileNet V2, the accuracy was the 80%. And the last EfficientNet V2 model I choose was 98%. So I will tell you this project decision and recommendation for this AI model. I will develop a model and final tell you what consideration I have to make of it. First of all, there are four major considerations. First is the merge with diagnostic service. Doctors are tired of distinguish many skin diseases one by one. If doctors judge the classified skin disease first based on picture of the skin disease classified through AI, it will be of great help in classifying them. It can speed up diagnosis and reduce the fatigue in diagnosing disease. Second is discovery of early patients. It helps people with suspected skin disease easily take picture of skin disease through the camera photo and send them to model to distinguish whether they are skin disease or not, so that they can go to the hospital early for treatment. So this can prevent infection in many people and speed up their recovery by detecting the disease earlier. And third is AI ethical considerations. Since it is a model that judges a person's body experiencing certain error, and generalization error can lead to a big accident. Therefore, the dependencies of this model should be limited and must be used with professionals. Last is the data accumulation. Data from new patients used in the hospital can be loaded and used for learning. This accumulation of data can increase the accuracy in multiple decreases disease, and it will continue to benefit healthcare in the future. Thank you for listening my long presentation, and this is my end of the presentation. Bye.